So the same concept, we are trying to find difference in means. Last time we had mu1, mu2, and they were independent samples in the sense that one was in Florida, for example, the other in Georgia. But this time, we are going to find difference in means for paired comparisons. And we all know what paired means. We have X and you have a corresponding Y. They are dependent on each other. Do you agree? One could typically, for example, you want to know the effectiveness of a drug or even therapy of some sort. Now, how do we usually assess the effectiveness of a drug or therapy?
We usually have like a control group that's not on the drug, a control group that is on the drug, and a control group that's on the placebo.
So, Sloan's answer, we have a control group and a treatment group. And we compare means. That's perfectly fine. It is a good example, but there is an issue with that.
Placebo?
Well, control typically is placebo.
Was they independent?
They are independent. In this case, these are, that would form an example for independent samples because what the treatment group will get is not the same thing what the control group will get. Do you agree? So even though that is a good example, one of the examples or one of the ways to measure the effectiveness of a drug or a therapy, those are independent samples. If I want to see dependent, or if I want to have dependent samples and say I want to measure the effectiveness of the drug or therapy, how should I do it? Don't know? I'll give you the answer. How about before some sort of a treatment after, right? So this would result in a dependent sample. Why?
Because you're collecting data from the same group.
Because you're collecting data from the same group or a same individual. Suppose I went in for a treatment and they want to measure if it is effective. Before I go in, they measure something and I get the treatment. Maybe 3 months later, 6 months later, I go back again, they measure it to see if the wall changes. It might be positive, it might be negative, who knows. But this would be dependent because whatever observation that was collected was from me before the treatment, and it is the same after. So it is paired. Do you see why we call it a paired comparison? Because they always go in pairs. And what is this treatment that we're talking about? In this particular example, it would be the drug or the therapy. And treatment is actually a standard term that we use in statistics. We introduce a treatment and we want to measure the effect of the treatment or the effectiveness of the treatment. And depending on the scenario, treatment could be anything. And when I do an example, it should make sense. Are we clear? Yes? So the entire hypothesis testing process will be the same. changes here and there, but the process is the same 5-step process. Good? So we conduct a study. We're going to assess dating experience. 1 is awful, 10 is great. We made that initial assessment based on the first day. So we want to see what happens the second day to Monday.
Can you read the ratings across for the after, because I can't see it.
For the after,
Yeah.
9, 10, 10, 10, 10, 9, 3, 4, 10, 4, 7. And we have a before sample, we have an after sample, and we want to verify the claim. So first we've got to sort something out. We'll call mu1 to be the average before. Mu2 is average after. And typically it's before minus after. That's what people usually do. So mu sub d is the difference in means. So mu1 minus mu2, which would simply mean the before average minus the after average. So what would a positive experience mean in terms of mu sub d? A negative number, very good. So positive experience doesn't imply that this has to be a positive number. It has to be a negative number because that would indicate that mu2 was bigger than mu1, right? After average is better than before average, which would imply a positive experience. So positive experience would mean mu1 minus mu2 is less than 0. In other words, mu1 is less than 0, less than mu2. So the average before is less than the average after, which would indicate a positive experience. So we'd like to know what the treatment is in this case. What is the treatment? Treatment is a standard statistical term that we use. So what are we trying to assess here? Dating experience. And specifically, what do we use to assess that in this case? The second day. Good. Okay. So this, I could rewrite it as mu sub d is less than 0. The same thing. Agreed? Okay. Now we can define the hypothesis. So in terms of mu sub d, the claim that we are trying to verify is mu sub d less than 0, correct? So, and that would be greater than or equal to or you can write it as mu sub d equal to 0.
Mu sub d is the difference, right?
Yes. The difference in the averages. So you look at that and you can tell me what type of test are we performing or about to perform. Right tail, left tail, two tail.
Left.
left hand. Alpha is 0.05, which would imply that the probability of a type 1 error in other words, if we rejected the norm based under the current norm, the probability of error has to be 5% or less. Step 3 is where we find a bunch of things regarding the data. So we have the before values, we have the after values. What do we need to find? We are making use of the differences, right? So we need to find the difference in average. So I believe D is the notation that the textbook uses, so we could just stick to that. Well, before we had 5, 10, 8, 8, 10. Seven, 9, 6, 8. After 9, 10, 10, 10, 10, 9. You've got to be careful when you find the difference, because you have to stick to what you defined as mu sub D. Even when you do the homework or the exam, read the question carefully and decide on mu1 and mu2 accordingly, depending on the question. So here we want to do 5 minus 9. So 5 minus 9 is negative 4. 10 minus 10, 0. 8 minus 10, minus 2. 8 minus 10, minus 2. 10 minus 10, 0. 7 minus 9, minus 2. 9 minus 3, positive 6. 6 minus 4, 2. 8 minus 10, minus 2. 7 minus 4, 3. 7 minus 7, 0. We see a bunch of negatives. It's sort of making us think, well, perhaps we are happy with this HSC students might actually have a positive experience. So what is the sample average of differences? Negative point 0.090. Okay, standard deviation.
I got 0.0909.
Okay, we'll put it as 1. So I actually know the conclusion even before we do the test, but we will do the test for fun. So we have the sample difference, we have the standard deviation. What is the fourth step in hypothesis testing? Typically, once we have the sample information and everything, we find the test statistic. So here, the test statistic has a t-distribution with degrees of freedom n-1. And the test statistic is defined as the estimated sample average minus the null value of the difference. In our case, based on the definition that we wrote mu sub t is less than 0, so that is our null value, therefore we just have 0. Over the standard deviation divided by square root of n. So the denominator part, SD divided by square root of n, is the standard error. We will make use of that when we find a confidence interval for this problem. So we know the difference, which is negative 0.091 divided by 2.84 over square root of 11. And what do we get? So that would be negative 0.11. What is the next step?
Conclusion.
To obtain a conclusion. There are two ways. We could either use the critical value method or the p-value method. Zero is right in the middle. So where should the rejection region be? Should it be on the left or the right?
The left.
The left, because this is a left-hand test. So on the real number line, the rejection region is right here. And what is the area that we would use to find the critical value? It has to equal to alpha that we set, which is 0.05. So the notation here would simply be T sub the area below, and the degrees of freedom, which is n-1. So T sub 0.05, 10. I'll write it over here so that you can see. And what is that value? How do we find that value? What do we use in our calculator? Inverse t, so inverse t, 0.05, comma 10. And what is that value? Probably negative 2, negative 3.
I got negative 1.812.
Negative 1.812. So we would reject the null if the test statistic fell below negative 1.812. What is our test statistic? Our test statistic is negative 0.11, so it's right over there. Did the test statistic fall in the rejection region? No. So test statistic does not fall in the rejection region, which would simply mean we do not reject the null. So there is no sufficient evidence to support the claim, which simply is the alternative. So did we find enough evidence? Well, there's none to begin with. So we don't reject the null, and there is no sufficient evidence to support the claim. Does that make sense? Since this is a left-tail test, the p-value is simply the area below the test statistic. And it's the same bell curve looking thing, so at 0 right here, our test statistic is negative 0.11. And we want to find the area below negative 0.11. Since the distribution of the test statistic is t, so we have to use t-CDF. Where does the area start? In other words, the lower bound for the area. Negative infinity, which is negative E99 in your calculator. Where does the area end? The area ends at negative 0.11. What goes next? The degrees of freedom, and what do we have? 10. Because it is n minus 1. Should be about 0.48.
0.457.
7 next decimal?
2 9 is a 3.
3. So the p-value happens to be 0.4573. Is that less than 0.05 that we set? No. It is greater than 0.05, which would mean do not reject null. This also suggests that based on the current data that we have, under the null, if I rejected the null and went with the claim, the probability that I could be wrong is 45.73%. Would you make a conclusion knowing the fact that the probability that you could be wrong is 45.73%? Absolutely not. Not only that, I permitted only 5% or less error. So 45% is just too much. So logically speaking, you should not reject the null. Does that make sense? Okay. Earlier, or maybe 2 or 3 weeks ago, I said if you use the software, typically when a test is done, you would always get the confidence interval also, because they are related to each other. So let's say a 95% confidence interval. How do we find the confidence interval for the differences? We find the confidence interval after finding the margin of error. So mu sub d is the average difference, and the sample average of differences, which we found here, which is negative 0.091. I'm going to add the margin of error. And subtract the margin of error. And I also mentioned that the margin of error is always the product of two things, and what are the two things? Critical value and standard error. Only this time, when we find the critical value, what should we do? Should we use alpha, or should we use alpha over 2? Alpha over 2. So the margin of error in this case is t sub alpha over 2, or we can use the positive side, so we'll do 1 minus alpha over 2, comma n minus 1. Critical value multiplied by standard error. So the critical value, what do we use to find the critical value in your calculator? Inverse t. So the area below here is 0.975. Degrees of freedom is 10. So all we have to do is plug in inverse t, 0.975, 10. And the standard deviation of differences is 2.84. And be careful, the denominator here is not n minus 1, it is n. So when you put that in, what do you get as the margin of error? So we have the margin of error to be 1.91. We know the difference is negative 0.091. So negative 0.091 minus 1.91, subtracting the margin of error. And add 1.91 to that. And what do we get? That's 3, 2, 8, 1. Is that right? Close.
Your first interval is incorrect.
Huh?
Your first interval is correct, it's supposed to be negative 2.00.
Negative 2.008.
Yeah.
And is that right?
It's 001. For the first, yeah, it's
001.
Be alone.
This is okay. Okay. So we concluded that we don't have sufficient evidence to say that the difference is less than 0. Look at the interval. Can we arrive at the same conclusion? Yes. Why?
The 0 is the bounds of it.
0 falls between negative 2 and 1.82. So if you want to visualize, you have 0 here, negative 2, 1.82. So our interval for the difference is right here. And since 0 falls right in the middle, we cannot conclude that it is less than 0. So by all means, we can conclude something statistically then. The difference is 0. Statistically, it is possible, even with that variability, we can conclude from a statistical standpoint that mu1 and mu2 are the same. Because from a statistical standpoint, the difference 0 is possible, so the difference could equal 0. If the difference is 0, then mu1 and mu2 are the same. So there isn't any difference before and after the second date as far as FTC students' dating experiences are concerned. Does that make sense? In a statistical standpoint. Earlier, I said, when I wrote that step, I mentioned that I know the answer already, that we will not be rejecting the null. How did I know that? I thought of mu hat d, right? And that value is close to 0. Agreed? Yes. And how do we form this interval? We form the interval by adding and subtracting from this tiny value. Yes. So this is approximately 0, and if I add something and subtract something from 0, 0 is definitely going to be right in the middle. Yes? So I knew the conclusion from the get-go as to what would happen. Good? So sometimes you don't even have to do a test. A little bit of thought would get you the right answer. Does that make sense?